Okay, loading this thing back up because, again, for whatever reason, it can't be preloaded. My recording software does not like smart notebooks. So here we go on number 24. What occurs when a magnesium atom becomes a magnesium ion? Might be best if I look up on the periodic table magnesium real quick because I need to know, right? See, magnesium is 282, so I'm going to lose 2 before I gain 6. So electrons are not going to be gained, they're going to be lost. And if electrons are lost, the oxidation number increases or the oxidation number decreases. That's fabulous. And there's a hint. If I lose these 2 electrons, I'm going to become a +2 ion. So my oxidation number is going to increase. And this is one of those topics that throughout the whole year has messed up chemistry students forever and ever and ever because the charge on the electron is negative. So when I lose it, I become more positive. We got to have that straight. Energy is required to produce a chemical change during. Boiling and melting are not chemical changes, those are phase changes, so I'm going to go ahead and cancel them right out. Chromatography is a separation technique that you probably did in living environment a little bit. You did paper chromatography, and you took the pigments of the leaf that came up the paper. Electrolysis is taking water, hitting it with electricity, and turning it into oxygen and hydrogen gas. So that is a chemical reaction. There are different things on the other side of the reaction. The reaction of an areneous acid and areneous base produces water and a generic salt. This is acid plus a base equals salt and water. That is a neutralization reaction. These three, aldehyde, halocarbon, and esters, are the organic reactions, and those are different reactions. During organic, we never talked about acids and bases, did we? So, because those are not organic, they have metals in them, like sodium or potassium, or potentially some other thing with the base, especially. So we got to know that an acid plus a base equals salt and water. That's a neutralization reaction. We find that in the titration. Okay, one acid-base theory defines an acid as, well, first off, I'm looking at these 4 choices, and we never deal with H minus. So I'm going to go ahead and cross those out. Then by definition, I have an H plus acceptor and an H plus donor. The donor is to give off and the acceptor is to take in. So acids give off H plus. Acids take in that H plus. So the acceptor is the acid definition. Okay? Which phrase describes the decay modes and half-lives of K37 and K42. So now this is nuclear chemistry, which is what we just finished last. So let me go to the table with the different isotopes. K37, K42. I see K37 and K42, which is fabulous. I see one is a positron and one is a beta. So their decay modes are different, and then one is 1.23 seconds and one is 12 hours. So their decay modes are different and their half-lives are different. And I learned that just by looking it up. I'm not going to lie to you, I had no idea. I just had to look it up. And that's what I need you to do, is to just look this stuff up. Which particle has a mass that is approximately equal to the mass of a proton? Now, this question I do not expect to see at 29. This kind of throws me for a loop because this is one of the electron, proton, neutron questions, which normally is at the beginning of the test because we do atoms at the beginning. Alpha particle and beta particles, this is nuclear chemistry. Say it was positron. Notice those 3 kind of things go together. Alpha, beta, positron, throwing it at the end of the test, using nuclear stuff at the end of the test. And the answer here is really just a neutron. A neutron and a proton have about the same mass. What's different is their charge. One's neutral and one is positive. Which change occurs during nuclear fission? Fission. Nuclear fission is the key word. I have fission and I got fusion. Fusions take 2 things, put them together. Fission is take one big thing and cut it into 2 smaller things. And what's happening in both, of course, is matter is converted into energy. That happens in both fission and fusion equations. We're not dealing with anything that has anything to do with covalent bonds. Isotopes are converted to isomers. That doesn't even make sense. And temperature is converted to mass. Temperature is energy. We don't convert energy into mass. We haven't been able to do that yet. And that is it for this page. I wonder how much longer we got. Let's try and get through this next page a little bit. Should we call it a video? We'll call it a video, and I'll come back and do this one next. Very good. Very good. Be well.